My name's Richard Conway. I run a company called Cloud, and we're all about cloud, big data, machine learning. Very, very close relationship with Microsoft, and we really want to try to sort of explain that Microsoft's cloud, Azure, is a really good story for all of these things and why we're using them and what kind of results we're getting. With my community hat, I also run a users group for Microsoft Cloud, so I see a lot of case studies around people that have put these things in place and none of it's worked, and then with that hat I can go screaming to Microsoft and tell them to fix things, which sometimes they do. I'm an Azure MVP and insider, and what that sort of means is that I get a lot of interaction with the product teams, which can sometimes be very good, sometimes be really, really frustrating, because generally in big software vendors they've got roadmaps that go on forever, and to try and get things introduced into these roadmaps is actually a lot of hard work. But I think one of the things for me about the cloud is this idea of cadence. Have any of you guys ever heard, do you talk about the word cadence regularly? Do you know what it is? Okay, so it's this sort of software development fundamental where, for years and years, people shipping shrink wrap software, and especially in the case of Windows, every 6 months you get a new service pack, and there's always problems with those, and then they have to have hot fixes and quick releases and these kinds of things. So the cloud and this idea of delivering software as a service brings in this idea of cadence. So all of a sudden you can do these sort of things that Amazon do very, very quickly, and continuously release several times a day. But you're not releasing anymore. You're not releasing any more hot fixes, you're releasing features. So this idea that you can continue to release these big products where, where we would have had to have waited 6 months for release with Office, all of a sudden you get this idea of cadence introduced, and then Office Online, the release will go in daily, or then that afternoon. So it's a very, very different model in terms of reacting. And I think this sort of new world with this Web 2.0, with Twitter, Amazon, Facebook, they really, really understand this idea of cadence, and it's something that Microsoft's beginning to do and catch up with. So I'll tell you about some of my experiences with that. I write a lot of open source code. I can write open source better than I can calculate time, because we're not going to be 10 minutes, we're going to be longer than that. And this is primarily just to sort of facilitate people getting on board the cloud, because there is a gap in understanding. And one of the things that we're finding when we talk to customers all the time, when people come to our user group, is that they think that it's going to be a really, really simple transition. We want to migrate something, we have something on a host, which Rackspace or any other host you can think of. And they think that sort of transition from host to cloud is just going to go utterly seamlessly. And evidently when it doesn't, that's when all the problems and the recriminations start, because I don't think yet people really understand this as a sort of fundamental in its own right. I mean, as I sort of take you through how I view the cloud, you'll see that a lot of it is really about interacting with this incredibly holistic set of services and virtual machines using APIs. And so, it's moving away from this idea of physical tin, where you have to provision everything, you have to install software, and you deal with APIs instead to have a whole set of management processes that you can automate. Okay, so is anybody using the cloud? Yeah? Which cloud?
Well, hosted services.
Hosted services.
Yeah.
Okay.
Hosted Exchange.
Hosted Exchange.
Online backups, etc.
Okay. Okay. Anyone else?
Do you consider Google Documents as a cloud?
No, I don't even consider hosted services as a cloud, really. I'm going to nod because I want someone in the audience to say yes. Does anybody have it on any kind of migration plan or roadmap? Okay, I guarantee you that you will in the next couple of years. So I think just to sort of go through some basic dictionary definitions, because I don't want to hop too long on this, because I think we've got a lot to cover around how we can use the cloud at scale to solve some very big problems. So the first thing with the cloud is it's a set of pooled resources. So, you know, companies like Microsoft and Amazon and Google, they can afford to buy big data centers. So we let them buy big data centers, and we multi-tenant basically. So there are lots of different people, and you know, we have the equivalent of tenancy, and we lease these resources for a period of time. And the granularity of this time can be to the minute now. Self-service. So traditional IT is used to this idea of IT operations and development. And now a lot of this has been synthesized with this new ideal called DevOps. Has anybody heard of DevOps? That's another hype buzzword. I'm not going to talk too much about DevOps today because I've got too many buzzwords in this. But essentially, the cloud is more oriented around DevOps because you don't have that physical affinity to equipment. So, you know, having to install software and having to do management in the same way as you have in the past is very, very different. It's all about automation and control, and using software to automate and control, and APIs to automate control of this. Then Elastic. So by Elastic, what we mean is that we want to build applications where we don't necessarily need to worry about running out of resources, because Microsoft's bought to date 14 data centers, and they're absolutely huge. I mean, if you ever visit them, they're just like scrapyards. You know, they go on as far as the eye can see. You know, some parts of them are becoming scrapyards now because the old Intels are so outdated that they're being trashed and sold on. New generation is coming. But that idea of elasticity is really important because you want to build applications that are horizontally scalable. If you have a website, for example, and all of a sudden you have these seasonal variations and spikes, you know, what's the traditional way of dealing with this? It's, you know, to order in more equipment, to provision it. You have to be really, really aware of your environment, you know, of your users and how and what your company life cycle is like to be able to do this. So to be able to use these elastic limits on demand is absolutely fantastic. We've never been able to do this with traditional hosts. Just say, give me a few more of these virtual machines because I need more resources. And lastly, usage-based. You pay for what you use. So some clouds charge by the hour, some charge by the minute. Azure charges by the minute now. So, you know, you're literally just paying to effectively rent these virtual machines for the time that you need them and no longer. So, sorry about the funny colours here. It doesn't matter how I cut and paste these, they always end up really, really loud and leery. So, so this is what we call the IT continuum. It's this idea that, you know, we go from physical infrastructure where we provision racks of servers and people are installing them with fans and, you know, all of this clever data center equipment to monitor it and switches and routers, and then we go from there to technologies like VMware and Hyper-V, which allow us to virtualize servers based on people sharing, tenanting a lot of equipment, so you can share the number of cores, share the amount of memory, share the amount of disk space, etc. And then we go into this idea of a cloud provision model. So it starts at IaaS, or infrastructure as a service. Has anyone come across infrastructure as a service? Okay, it's a way of provisioning virtual machines. So essentially, if I want to have a Windows server, or if I want to have a Linux server, within a few button clicks, I can customize this and build some software and agents and all of the things that I need to very, very quickly. Then I still have to manage the life cycle of that software, so I have to worry about operating system updates, I have to worry about software updates, and a lot of these things which IT operations would normally do. But the cloud takes it one step further. It introduces this idea of platform as a service. So it treats the operating system itself as a platform. It says, I'll manage all the security patches, I'll manage all the patches for your web server, I'll manage everything that's a headache for you. So, so that's platform as a service. And then lastly, we have this idea of software as a service. So vendors are now saying, well, what can we do that's just going to alleviate the headaches? Do you build web applications? Can we give you a web server as a service? So that all you need to do is interact with a web server API, and you don't need to worry about FTP and all these complex and arcane protocols. And we'll just give you an API, and you can do everything with it. Similar with mobile backends now. There are a growing number of mobile developers, and they're using all these client-side technologies like Objective-C for the iPhone, C#, games developers that use Unity, but they don't necessarily have all of these database skills to build these server backends. So there are services now that are just for mobile developers, which are built and provisioned on top of cloud. So, this is very, very much becoming like the, what is traditional in computer science, like the OSI stack. Where we have layers and layers of abstractions one on top of each other, which is now representing what a cloud is. So a very old slide, but just to give you an idea, I'm going to be focusing on Microsoft's cloud today, but and some of these slides are applicable to that, but these things are synonymous with a lot of, well, I say a lot of other clouds, but mainly with Amazon and Google, that are the same sort of size as Microsoft. But this just gives you an idea that Microsoft is the biggest consumer of their cloud. Essentially what they've done is they've moved all of their services into Windows Azure. So I don't know whether any of you have got kids who play the Xbox or like me play the Xbox with your kids.
PlayStation.
PlayStation. Hosted on Amazon, but still, I met a Sony developer the other day who actually does all the work on Amazon, and it's incredible how the entire backend for games has been ported to cloud. Very recently there was a release of Titanfall, which had this huge reception. So that went live on day one, mainly with no problems, backed by 300,000 cores in Microsoft's cloud. So this is the sort of legacy that games are bringing, this huge scale of compute. I was recently in a Guinness Book of World Records attempt where we were helping judge. It's supposed to be independent. I don't know how independent we are since Microsoft are actually our meal ticket, but we were supposed to judge the technology behind a gaming attempt to surpass. There's a really prolific online game called EVE Online, and it had the biggest gaming universe, and it's actually really difficult to design these to scale because when you deal with a lot of these services, especially around gaming, you've got to manage so many connections, and this is perfect for scale-up technology. So put your software in a bigger box, but in the cloud you can't always do that. So you have to redesign things so that they scale out at different tiers. So we did actually judge this game. I felt really sorry for the devs who spent 3 months building this with between Microsoft and a company called Illyriad. The technology was absolutely fantastic, and Microsoft marketing totally failed them by getting, I think, 10% of the users online that they needed to actually win this. But the tech stood up really well on the cloud. Okay. So just to give you an idea of scale, and again you can see this slide is over 2 years old, but this is absolutely huge. I mean, you cannot even envisage. If any of you do use these clouds, you can speak to any of the cloud vendors and ask for a data center tool, and normally they'll schedule it. It's worth going just to see how amazingly big these places are. You can't even conceive, you know. It's nothing like any host or any data center that you've ever seen, and they just keep scaling them more and more. This slide is so out of date, it's unbelievable now. There's four data centers in the Microsoft Cloud. There are 4 data centers in the US, 2 in Europe, 2 in China, 2 in Japan, 2 in Southeast Asia, 2 in Australia, 1 in Brazil. Second one's coming online. There's another one in Finland, which is not on there, and there's about 50 point of presence nodes for a CDN, a content delivery network. So these are actually coming online quicker and quicker now. The US data centers are totally at capacity. They're having to build 4 more. So this sort of trend of moving away from on-premise, or even moving to new sets of services, people moving from Office to Office 365 and storing all of the documents online. It's such a fast-paced trend now, that even the vendors are having problems keeping up with the capacity. So this is sort of what a data center looks like. I mean, as I say, there's so much space there. Each of these containers is completely self-contained, and they're driven into the data center on the back of a lorry, which backs in, and there's a set of power which they're plugged into. It's all sort of modular design, and then nobody touches it. And what I mean by that is that they're completely fully automated. So things like airflow is changed based on different parameters and different sensors in there. It's a really sort of dynamic unit. Unless there's been critical failures of routing hardware, when some of these machines in the rack go, that's it. They're just left there until they reach a critical mass. So it's a very, very different model from in terms of security as well, whereby you don't have physical access to these places. So to get on this data center floor, you can see there's a whole load of open space here, and you're very, very visible. You have to get through key cards and fingerprint scanners, and there's guards with dogs and guns around these, and you just don't get in, If you do get in, try and find someone's data in there, I mean, it's utterly ridiculous, you've got hundreds upon hundreds upon hundreds of petabytes of data, I mean, how do you steal commercial secrets? I mean, you could send a fleet of lorries in there and just steal everything if you wanted to, but there's probably some secret security in there, I don't know. Well, the NSA managed it, but but I think it's a really sort of different. There's a lot of different arguments, and a lot of people tend to confuse security and compliance when they talk about the cloud. The cloud, i.e., these data centers, are highly secure. They might not be as compliant as traditional data centers, but this is changing as well. Microsoft has actually got a trust center where I think every 3 months they go through these quarterly cycles of getting new compliance regulations passed. So I think now they've got PCI compliance, and they've got people doing storing credit card data and things like that on it. So I mean, it's changing, and now I think they gained IL2 compliance as well. So if that means anything to anyone, it's government data they can store at the sort of lowest level. But it's looking like as well that they're going to have set types of cloud. So I think government compliance goes to IL3 and above. And one of the things that they're trialling in the States is to have specific government clouds for for specific government compliance. So I think that sort of model will be brought to the UK soon as well, which will really open the spectrum of use for the public sector. And then just look at traditional patterns. Sorry, I grabbed this slide from some research projects that we were doing and talking about, but this sort of applies to anything. You know, classic batch workloads. You know, I need to run a job at night and I need some computing resource to do it, but I don't need anything in the morning. So why pay for it during the day? And you know, this is the classic case of getting in the tin, running your software on it, and then just paying for that all the way through. And if you sort of work out the economics when you're running a workload like this, you know, the cloud is very, very friendly to these scenarios. Then there's this idea of you know, of growing fast. It's really difficult to anticipate how much you need when you're growing, especially when you're a small business. And you tend to have, this graph tends to look a lot more stepped.